So this slide is table 9.2 straight from our handbook. This is covering typical trench width. So as you're getting ready to cut a trench, then the first question is, how wide do I need that trench to be? Well, the answer to that is that you need enough working room on either side of the pipe that you can get in there and you can do the compactive effort that's necessary. If there's people in the trench, it's a safe zone for a worker to be down there. Depending upon the type of compaction equipment that's used, there's enough room for that equipment to get in the trench. So that's really what dictates trench width. And this table is labeled typical because it's making the accommodation for most of those scenarios of working room. And so it's picking up the pipe diameter plus the working room on each side. And so that's the table that you see here and in table 9.2 of the handbook. Now, as you're talking about trenches, I think it's only natural here to kind of give a brief safety pitch. Once you've cut a trench, safety becomes a concern. Right. And you want to protect the safety of the people working in and around the trench. And so OSHA is where guidance is provided for that type of work. One of the specific OSHA guidances that we list here at the bottom is the OSHA guidance for using a trench shield. Okay, and that's what we're going to talk next, but there is a specific OSHA guidance for using trench boxes or trench shields. A trench box is what is over here on Greg's side. That's a typical look of a trench box. It's really just to keep the sidewalls of the trench in position and protect the person working in the trench. Now, the important part of this working in a trench box with a trench shield is that despite having a trench shield in place, the compactive effort needs to take place against the native soil. And so you see in this illustration, the trench box is benched up above the bottom of the trench, and that would be where compaction can take place to make sure that this material is compacted against the native soil. What you don't want to happen is compact that sidewall against the trench box itself, because then when the trench box is moved, your compaction is gone at that point. Right. From an OSHA standpoint, 24 inches is the maximum freeboard that's allowed. Yeah. So if you're working with any pipe over 24 inches, then you're going to have to bring it up a couple of times. Right. And to do it safely. Right? You can do that in a specific cut bench where they bench it, or I've seen where the sidewalls and the material actually works to their favor, where they can actually lift it and it bites into the sidewall, and then they lift it again and it kind of bites into the sidewall again. Now that's how I've seen it most. Right. I don't know if you have anything to add there.
No, that's the same, and it's really important because we'll get to the pipe embedment and the haunching in a minute. But that spot where Dan pointed to, it's very important to make sure we get good material in that spot, in that location to support the pipe. And if that box is moved in any way or disturbs or disrupts that material, then again it affects that embedment in that location, which could eventually affect pipe performance long term.